Hi, good morning, good afternoon. My name is Keiko Onichika. I'm the CEO of HighRI Optics. Happy to be presenting this phase 2 work on the development of anti-reflection coating on optical window surface. Now, the anti-reflection is nothing new. It's been already used in a variety of technologies. What's new, what we're trying to develop is an additional functionality to the anti-reflection coating. Which will include anti-fogging, corrosion resistance, water repellency, and self-cleaning properties so that these anti-reflection coated optical windows can be used in a variety of environmental conditions. Our company is HighRI Optics, and HighRI stands for High Refractive Index Optics. And as the name indicates, we specialize in the development of new optical materials and breakthrough nanofabrication technology to enable advanced photonic applications. We were established as a spin-off company in 2019 in Bay Area, California. The parent company was eBeam Technologies, established in 2003 and sold to Hitachi and HT in the USA. Our group is a winner of R&D 100 award prior to the spin-off to the HighRI Optics. We have set a world record in nano imprint lithography, and we have 2 granted patents related to the optical material. And we have a very strong technical members and a board member, and all hold PhD degrees among chemistry, material science, and optics. We also have a facility access with the state-of-art nanofabrication system as well and the production factory for volume manufacturing of the material. And we also have a proof of commercialization of our development funded by the SBIR. In particular, we have a licensed patent and a technology know-how to a multi-billion-dollar chemical company for volume manufacturing of the new optical material, which was previously funded by Air Force. The key Navy challenges we're trying to address are the following. Number 1 is the need to maximize optical transmittance. Number 2 is the need to minimize the sun reflection. Number 3 is the need to remove the water from the optical window surface quickly so that no imaging or sensing capability is compromised. And currently, there is no anti-reflection technology that answers all of these needs. And so that's what we are trying to address and develop the technology that has a property of high performance anti-reflection and water shedding property and corrosion resistant. So this anti-reflection coating can last in a harsh seawater environment for a very long time, maintaining optical performance. The system requires optical windows which are anti-sun glare, hydrophobic, and reliable and robust. And the technology must satisfy all of these all at the same time, not just one of them. And HighRI nanostructured coating will provide these capabilities and suitable for imaging application and last a very long time under the seawater environment. Our company will achieve the technological goals by nano-patterning the optical window surface with random anti-reflection nanostructures such as shown over here in the scanning electron micrograph. We're using the replication-based method, which in other words, we're using a stamp and to apply these nanostructures onto the optical window surface. Normally, without any anti-reflection, a piece of glass will have reflectivity about 8%, which means 8% of the light is lost. By applying these anti-reflection nanostructures onto the glass surface, we can reduce the reflectivity down to 0.05%, which we have shown earlier, and which is a remarkable about 150 to 160 times improvement in the anti-reflectivity. And by nature of these nanostructures, we can achieve the broadband. AR property will work for all the broadband, all wavelengths of the light, and it can work for the wide angle. And it is coated with hydrophobic and corrosion resistant material, so the water can shed very easily and it can withstand harsh seawater environment. And as I mentioned, it is a reproducible technology based on the replication and a stamping method, so that the reapplication cost can be reduced. The current status, we're still in the first year of the phase 2. Current TRL level is number 4, and we are delivering the prototype in early 2022. It's very shortly after this talk. And the first year we have focused on the validation of our surface coating approach in validating that it will last in the seawater environment for a very long time and under the sun. We have done the validation using the small scale windows. And once that's fully demonstrated in the following option 1 and option 2, we're going to scale up the technology to the full size windows, and we've also performed a sea environmental test as well as for military spec evaluation. The key features and advantage and benefits that brings through this technology is minimize sun glare, broadband, and a wide angle reflection. It naturally sheds water, and it is easy to clean and safe to touch. And this is a key differentiator from the other already available technologies. And normally, anti-reflection nanostructure are known to be fragile, but we're adding additional surface coating to enable safe to touch and easy to clean properties, so that the window can be usable in these harsh environmental and operational conditions. And finally, it is the low cost of a replacement because of the replication technology we're using. The technology transition, what we foresee is that we need to do the full mil-spec evaluation on the full-scale AR-coated window. And we also need to do verification of at-sea performance and the reliability of AR-coated windows. We need to understand if and when and how the AR coating fails, and so that we can mitigate the risks. And we are looking for prime contracts for collaboration to do to help us with some of these evaluations. And the key technology can be scaled to support a wide range of applications, and for example, nano patterning of AR structure to curved optics, plastics, and etc. And AR structures on hard to handle or hard to the etch optical material, and optical elements to guide the light, for example, waveguide, which is highly related to the commercial application we are also seeking for. And in the past, for the detection technology for other agencies throughout the government, we have previously demonstrated 41% gain in the light extraction from scintillators through the DNDO, Domestic Nuclear Detection Office project, SBIR project with another company. And for more the commercial sector, nano imprinting of optical elements, including anti-reflection nanostructures, are strongly desired in the low-cost consumer markets. And one of the very the hot application is the waveguides for AR. In this case, it's augmented reality, virtual reality head-mounted display. And the waveguides is one of the key components for the immersive experience. And the companies are looking for ways to inexpensively pattern the waveguides. Waveguide dimensions are quite similar to these AR anti-reflection nanostructures. Also, the micro lenses and the anti-reflection surface on the consumer electronic devices. The types of partners sought for a transition, and we're looking for a prime contractor and a manufacturer optical system viewing windows, and we believe the funding will be necessary to build a full-scale production capability. And we are also interested in organization or companies for collaboration that are looking for capability to reduce production cost by nano imprinting and or the optical elements for a signal gain and reduce loss. And our likely path forward is manufacture AR-coated windows, sell the products to periscope manufacturers, or the licensed patent and know-how to enable high volume production. With that, I look forward to connecting with you. Let's discuss your needs. Our company again is HighRI Optics. My name is Keiko Munechika, and you can reach out to me through this phone number or the email address throughout this event or after the event. I look forward to talking with you for any inquiry for our products and potential collaboration, any other interest. Look forward to meeting many of you.